So today we have 3E or 3-5 notes. Again, we're continuing with trigonometry. Today is inverse trig. So we're going to use the same SOHCAHTOA that we've been using, but this time we have inverse sine, inverse cosine, and inverse tangent. These are used to find angle measures, and we were finding side lengths, but we use the same SOHCAHTOA. It's still the opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, opposite over adjacent for tangent. So that doesn't change, but what we're finding changes and how we enter it in our calculator changes. So we have 4 steps for solving for angles using inverse trig. So just like before, our first step is to identify opposite, adjacent, hypotenuse, and then decide which trig function to use based on the SOHCAHTOA. Write it out, plug in your side lengths, rewrite the equation to inverse trig, and use your calculator to solve. So let's start with example 1A. So first step, identify opposite, adjacent, hypotenuse. Remember, we're looking at this theta here. So based on that one, this would be adjacent, this would be opposite, and this would be our hypotenuse. And we need to decide which trig function to use. So I'm going to write out SOHCAHTOA so we can decide which one we're going to use. So based on this angle, I have measurements for adjacent and measurements for hypotenuse, which means that I'm going to use cosine. So if I write out what we normally do, so the cosine of theta equals adjacent over hypotenuse, so 18 over 27. But now what we're trying to find is what is theta? And that's what we're going to use the inverse trig. So theta equals inverse cosine of 18 over 27. And now we're going to use our calculator to find this. The steps to do this in your calculator would be to press the second button, and then you want to press whichever one you're using, sine, cosine, or tangent. So for this one, we are using cosine. And then you're going to enter your fraction. And when you do that, you should get 48.19 degrees for theta. Okay, let's try B together. So, write out SOHCAHTOA. We're going to label we have opposite and adjacent. So we're going to use tangent. The tangent of theta equals 4.2 over 3. So now we're going to use our inverse function, inverse tangent. And we use the same steps in our calculator, but instead this time we're going to press tangent. And we should get that theta equals 54.5 degrees. Okay, I want you to try C on your own. Pause the video, try it, and then come back to look for the steps. Okay, so I skipped one of the steps and I just went right to the inverse, which is fine if you can do that. And then I rounded and I got 56.44 degrees. If you round to 1 or 2 decimals, I don't really care. Okay, example 2. If you look here, it says find all missing sides and angles. So we're going to just be given a little bit of information, but we have to find everything. So I'm going to start, as always, SOHCAHTOA. So I'm just going to pick one of these angles, and I'm going to label it as theta. So let's say this one's theta. So going from this one, this is adjacent, this is opposite, and of course this is hypotenuse. So we have an opposite and an adjacent. So we're going to use tangent. And since we're finding an angle measure, we're going to use the inverse. Now you could write out tangent of theta equals 8 over 10. And then once you do that, you're going to realize you can't solve anything with that. And so we need to use the inverse. When we do this for theta, we should get 38.6 degrees. Now, we have 2 ways we could go about solving for the next angle. I'm going to go ahead and just label this one alpha to distinguish it from the other one. We could use our angle triangle sum theorem and do 180 minus 90 minus 38.6 and get 51.4 degrees for alpha. Or you can solve for it by using the inverse tangent function, because from that angle we would have opposite and adjacent, and you would get the same thing. I think it comes out to be like 51.3 degrees. The rounding's just a little bit different, but either way would work to solve for it. So we have solved for both of our angles, and now all that's left to do is to solve for the side lengths. You could do some more trig functions, but honestly the easiest would be to use the Pythagorean theorem. Oops. There we go. So C equals 12.8, which is the hypotenuse. Okay, let's go on to this next one. Feel free to pause this and try this one on your own, but I'm going to work through it as well. So the first thing I'm going to do is solve for this missing angle here. Let's call it theta. This one we don't actually have to do any trig for. Can if you want. But we are already given 2 angles, right? 90 and 62. So if we have 180 minus 90 minus 62, then we get that theta, or our missing angle, is 28 degrees. Now we need to find all the side lengths. We're given 1. I am going to go with the 62 degrees because that one was already given to us. And let's say you accidentally made a calculator mistake and you went with this one, the 28 degrees one, then all of your calculations will be wrong if you messed up on the first one. So I would always go with what's given. So I'm going to go with the 62 degrees. And then to figure out what we need, we know that we are given 10, and then let's go ahead and try to find this missing side here. And I'll call that x. So that would be adjacent, and this would be opposite. So which one uses adjacent and opposite? Tangent. So the tangent, and now we're given the angle measurement, so we can go ahead and put that in, of 62 degrees equals 10 over x. And then to solve this, you do tangent of 62 divided by 10. So we would get x equals 5.3. And that's our measurement for one side. Now we need to find the hypotenuse, and I'm going to label that y. Again, you could use the Pythagorean theorem here, but since we have decimals and we're not 100% positive that this one is correct, I mean, I can tell you it is, but when you're taking your test, you might not be 100% positive it's correct. So I'm going to go ahead and use sine. So the sine of 62 degrees is 10 over h. And I got that because from 62, this one is still opposite of 62, and then y is our hypotenuse. So then we would get that h equals 11.3. And there's no inches or meters, so just writing that out is fine. For these, just make sure you box in all of your answers and have them labeled so I can see. Now we have word problems. Again, just like angle of elevation and depression, like our ladder problems that we were doing, this is all very similar. So again, I would just write out a picture. So here we have a 90-foot escalator that's rising 28 feet vertically. So I'm going to draw an escalator here that is 90 feet, and it's rising 28 feet vertically. What angle does the escalator make with the floor? So here's our escalator and there's our floor. So we are looking at this angle. That will be our theta. Write out our SOHCAHTOA. If you don't need to write this out every time, you don't have to, but I do because it helps you guys see what I'm doing. And so we have these two angle measurements, which are the hypotenuse and the one that is opposite. So which one uses hypotenuse and opposite? Sine. So the sine of theta equals 28 over 90. Well, we want to know the angle measure, so we're going to use the inverse sine. And we get that theta equals 18.1 degrees. Okay, you can pause the video and try this one on your own, and then come back for the steps. All right, check your steps with mine. And that is all we have for these notes. And this is the end of the unit. So make sure you go back and review all these things that you know about triangles and how to find all of the angles and all of the sides.